This is exercise number 8 from chapter 9. It says that the mean number of sick days an employee takes is believed to be 10, but members of personnel don't believe this. And so they randomly select 8 employees and they take the number of sick days from each of those employees this past year. So they want to know if the personnel team should believe this mean or not. So it looks like our setup would be a mean that's equal to 10, which will end up being your null hypothesis, and your alternative hypothesis is to say that mu is not equal to 10. It depends on what point of view you're looking at. You can see the claim as being what the personnel team actually believes. They don't believe this figure, so they believe this alternative hypothesis. Or if they're testing this claim, then they're looking at this claim, and that's the actual statement that they're putting through the test. I think it might be good if we look at it from this point of view to say that this is what they're claiming. They're trying to disprove it, so they're going to claim that it's not equal to 1, not equal to 10. So let's call this our claim. Now let's take a look at what we have for our data. We have our data here. We're 8 employees, and we got these numbers. So what we could do is we can punch in our calculators and find the mean and the standard deviation, the sample mean and the sample standard deviation, and then we can use this information to compute your test statistic and your p-value. But instead of doing that, we just hold back and we're going to let the calculator do all the work for us. One important thing to look for is a standard deviation that's assumed to be the population standard deviation. If we scan through this problem again, we'll see that the standard deviation is not known. And so the fact that it is not known says that we can probably use the appropriate distribution. We're going to use a t distribution, and it's going to be t sub n minus 1 or t sub 7. So we're going to use a t distribution for this. In a test situation, hypothesis test situation, we're actually going to use a t-test. Okay, so let's take a look at the t-test. We're going to go to our calculators and go ahead and hit stats and test. Before we do that, in this case we're given the data, so we're going to input the data in our list. We'll put it in our L1. I already did that, and so let's go through the test. Second one down is our t-test, and this time we have the data, so we're going to select data, and the calculator is going to ask us, okay, what is our mu that we're testing? The mu that we're testing is 10. So let's go ahead and punch 10. Next thing they ask for is, since we're choosing data, where's your list? What list? Where'd you put the data? Our data is in L2. I'm sorry, it's in L1. Let's try that again. Second function, the number 1, enter. We'll go with a frequency of 1, and then here they want to know what your alternative hypothesis is. Is it a not equal to, a less than or equal to, or a bigger than? Going back to our problem, our alternative hypothesis is a not equal to. So we're going to select that while it's blinking, and then we can calculate. We can have it draw too, but I think let's just have it calculate. Okay, we get some pieces of information that would be good for our problem. To note our test statistic, since it is a t-distribution, uh, it's a t-distribution, we have our test statistic given as a t, so t is equal to negative 1.12. Our p-value is a whopping 0.2996, and compared to, well, we don't have critical or a significance level. So there's a lot of freedom in making your conclusion. In general, if you don't have a significance level, we usually like to use 0.05 as a marker of sorts. And clearly our p-value is large. And with a large p-value like this, anything that's bigger than, you know, 0.1 or something like that is considered a large p-value. So that means there's nothing out of the ordinary there, and we're not able to reject the null hypothesis. So we can make that conclusion. Let's just say we are not able to reject the null hypothesis, and so that's a hypothesis test statement of our conclusion, but we actually wanted to make our own conclusion with try to make it in non-technical terms. And so we could say we did not reject the null hypothesis. So should the personnel team believe the mean number is about 10? It looks like they have no reason to believe otherwise. So because the mean of 10 days was not rejected. The personnel should believe that the mean is about 10. So there was no reason to believe otherwise because we were not able to reject it. And so, not that they should really accept it, but they should just believe that it's true. Okay, so that is problem number 8. It's another example of hypothesis testing and using a different distribution.